Hi kids, welcome to my Fearless Algebra 2 class. Been trying to come up with a name for you guys, but haven't had any success yet. So I'll just ask you, what do you call a car that has no wheels? It's stuck, of course. And then, in a similar fashion, what do you call a cow that has no legs? Well, it's ground beef. So I'm going to go ahead and do section 1.2 right now in our book. It's sums of polynomials. We talked about this in class on Tuesday. We were still sort of getting into things, so let me go ahead and teach through this section. I think that's what I'm going to do with every video that I do. I'll go ahead and work pretty much step by step through what your text says. I'm not going to read it to you, except occasionally I might read what it says, but I'll go through and explain it because math books can be really difficult for people to read. They're not particularly enjoyable, and they don't have those wonderful lame jokes either. So, sums of polynomials. First thing we have to come up with is, let's just read part of this on page 10. It says that polynomials are simple algebraic expressions formed by adding together even more basic expressions that are called terms. So what we have to come up with is an understanding what a term is when we're talking in algebra. A term, it might be a semester long in college, but a term means something completely different in algebra. So a term, when we're talking about algebraic expressions, they are add-ins. Add-ins means that you're adding or subtracting them, because subtraction is the same as adding the opposite. But what they're made up of is a variable. For example, if we just have x, that's a term. Or a number. For example, the number 4 is also a term. Or it can be a product of numbers and variables. So it could be something that looks like this. All of these are examples of terms. And let me just go ahead and do my basic classic example. 2x is an algebraic term. And Laura, this is how I make my x's. They're always sort of scripted. Sometimes people think they're 4's, but they're not. So this is an algebraic term. What makes it an algebraic term is that it has variables with it. So the numerical part, right there, that's called the coefficient. And the letter part, or the variable, is just called the variable. What's important to remember is that, because they'll be talking, you'll hear the word coefficient used over and over and over and over. And the coefficient is the number part that is stuck right in front of the variable. Here we have the product. This is 2 times x. So this is one term. The coefficient is 2. Okay? Now we're going to talk about polynomials. Polynomials are a collection of terms. So x, 4, 2xy squared, that's not a polynomial because this says that a polynomial is formed by adding together terms. So we can make our sample here into a polynomial if we just change these commas into addition signs. And then you have x plus 4 plus 2xy squared. And that's not the order that you would typically find a polynomial arranged in, but it does change this into a polynomial because what we have here is a collection of terms. We have the term x, the term 4 and the term 2xy squared, and we're adding them together. X plus 4 plus 2xy. They're terms because they're added together. Well, what would happen if we had x plus 4 minus 2xy squared? Would that still be a polynomial? Yes, it would. This is a polynomial, just as this is. But didn't I just say you have to add the terms together? Well, subtraction can also be written or described as adding the opposite, 2xy squared. So in this form, this is the addition of 3 separate terms. So these are what polynomials are. This right over here, 4xyz, there's only one term here, because this is 4 times x times y times z. So this is one term. This, all 3 of these, have 3 terms in them because they have to be separated. The terms are separated by addition signs. You know, you're adding terms together. One term plus a second term plus a third term. One term because it's the product of 4 times x times y times z. 3 terms because it's the sum of x and 4 and 2xy squared. Okay? Now, when we have algebraic terms that we're working with, you also have things that are called polynomials. And what polynomials are is a collection of terms. It's the sum of a number of terms. And those, we have some specific names for polynomials that are based on how many terms are contained in it. Let's say that we have 4x cubed. It's an x. How many terms are here? There's just one term, 4 times x squared. We're not adding anything. When we have the product of coefficients and variables, it's still just one term. This is called a monomial. Separating it out like this so that we see these prefixes. Monomial. How many terms do we have here? 4x cubed plus 4x squared. Well, you have 2 terms for this second example here. 4x cubed, this is the product of 4 times x times x times x, plus the product of 4 times x times x. Because we're adding together, we have one term plus another term. You all know what bicycles are. So you definite bipeds, binoculars, 2. So you have a binomial. Binomial. How many terms do we have here? Well, you know where I'm going, don't you? 4x cubed plus 4x squared plus 4x. 4x cubed is the product of 4 times x times x times x. That's a distinct disadvantage of a whiteboard. 4 times x times x plus 4 times x. There are 3 terms here. What Latin prefix do we know for 3? Tricycle? That's a trinomial. And then poly, what is poly? Polygon? Poly is many. A polynomial, 4x cubed plus 4x squared plus 4x plus 4y. Well, that has 4 terms. So a polynomial is generally the way we use polynomial is, if you think of a polynomial, it's a big collection of terms, but these 3 specific types of definitions here are monomial, where you have 1 term, binomial, where you have 2 terms, trinomial, where you have 3 terms. Those are all considered polynomials also. So a polynomial and a trinomial, a trinomial can be called a polynomial or a trinomial. A binomial can be called a polynomial or a trinomial. A monomial can also be called a polynomial. Now that messes with my head because I think many and one are 2 opposite things. And in actual use, most people aren't going to call a monomial a polynomial, but you need to know that technically it is, all of these are considered polynomials. Just more vocabulary. So let me go ahead and erase this. And the next thing that we want to talk about is the degree of a polynomial. More vocabulary. The degree of a polynomial. Polynomial. And I'm going to go back to this text, and it says the degree of a polynomial is the degree of the highest term in that polynomial. You can determine the degree of a term by adding the exponents of the variables in the terms. A constant has a degree of 0. So, what we have here, let's just see what this means. We have this term, 2xy. The constant term, remember, is the number that's in front of the variables. Rachel, if you need to ask me a question, you can. Okay. Where are the rest of them? Look on my desk. 2xy. The 2 is a constant term because it's just a number and it doesn't have an exponent considered along with it. We have x there's 1x, so this is the exponent is 1, is understood to be 1. The exponent of the y is understood to be 1. So this is a monomial of degree 2. 1 plus 1 is 2. Okay, now let's see if we have 5x squared y. What would the degree of this polynomial be? It's easy. You don't count the degree of just a single constant term. Then you just add the exponents on the variables. This is degree 3. What you have to remember is if there's not an exponent on the letter, not an exponent on the variable, it's understood to be 1. So you have to remember to add the 1 that isn't written down. So we say we understood to be 1. The exponent on a single factor, on a single algebraic factor, a single variable, is understood to be 1. Remember to add that when you're considering what degree. Remember to add this to find the degree of the whole entire polynomial. So now let's look at this one. If we have minus 4a cubed bc squared. bc squared. What's the degree of this going to be? Well, it doesn't have anything to do if you have a positive coefficient or a negative coefficient, because we're not worrying about the coefficients. We're not knowing about the numbers that are factors. This is a factor of -4, a factor of 5, and a factor of 2. We're not worrying about those at all. We're only going to sum the exponents on the variable. So is it 3 plus 2, which would make it degree 5? No, it's not 3 plus 2. It is degree 6, because we have 3 plus 1 plus 2. Remember that the exponent is understood to be 1 when you just have a single factor of the variable, and you've got to remember to add that. Okay? Now, the degree of a polynomial is tied in to the degree of a term. But what you have when you're finding the degree of a polynomial is you have to take, you consider all of the terms that are in that polynomial, and you take the highest degree, you take the degree of the highest term as the degree of the variable. 2x squared y plus 2x squared plus 2y plus 2y squared. Now I want to review what we talked about on Tuesday is combining like terms. If you have a variety of fruits, you have apples and oranges and peaches, and somebody else has some apples and oranges and peaches, and I say, let's combine the things that are like, you're going to say 2 apples plus 4 apples is 6 apples. 2 bananas, 1 banana gives us 3 bananas altogether. 2, I don't remember what I said, oranges. 2 oranges and 5 oranges, altogether we have 7 oranges. But you cannot combine oranges, apples, bananas, and pears without getting a fruit salad. So, similarly, in algebra, when you combine things that are the same, we've got x's and y's, but like terms have to agree both in the variables and in the degree. So if you're not really clear on what like terms are, like terms, they agree in variable and exponent or power and exponent. So we have x squared y. We only have an x, only have y's. So there are no terms that are like terms to this. We have a 2x squared, but over here it's a 2x squared y, so since the variables aren't the same, they're not considered like terms. We have 2y plus 2y squared, you can't combine those together. This would be maybe sort of like saying 2 oranges plus 2 tangerines. They're similar, but they're not the same. Now we have a variable of y, but here it's being used once as a factor, and here it's being used twice as a factor. So the degree of a polynomial, what you have to do is if we wanted to find the degree of this polynomial, we have to consider each term individually. See what the degree of each term is. 2 plus 1, this is degree 3, x squared, degree 2, y to the first, degree 1, y squared, degree 2. So what's the degree of the polynomial? Well, this right here is a 3rd degree polynomial. And that is because polynomial, the highest degree of any term that's in here is the 3rd degree. That's all that's involved in finding the degree of a polynomial. Let me come up with one more that is a little bit bigger, just to reassure you guys, just so that you guys are reassured that you completely understand what's going on here. Let's find the degree of 4 x cubed y z plus 7 x squared y plus, minus 15 x to the 4th y cubed z squared plus 2xy z. Got a little bit messy there at the end. Let's see what degree we have. We have 3 plus 1 plus 1, so that's degree 5. 2 plus 1, degree 3. 4 plus 3 is 7, plus 2 is degree 9. 1 plus 2 plus 3. So what degree is this polynomial? Do we just say 5 plus 3 plus 3 is 11 plus 9 is degree 20? Is that what our degree is? No. The degree of this polynomial is degree 9, because what you do is you find the degree of each individual term that's here. You determine which has the highest degree. This third term here, minus 15x to the 4th, y cubed z squared, has the highest degree, so that's the degree of the variable. Okay? Now we had talked just a minute or two ago about like terms. That's what we're going to do right now for this next part of the section. I'm going to grab a sip of coffee. See, I can do that because this is a less formal video. And our next example says, let's combine 3x squared. Combine 3x squared plus 2x minus 8 with the quantity 5x squared minus 3x plus 9. Minus 3x plus 9. Now you do have to remember order of operations, which tells us that when you have parentheses being used to group items together, you have to perform whatever operations are inside those parentheses first. So let's look. We have 3x squared plus 2x minus 8. Do we have any like terms within here? No, because remember, in order for terms to be considered like terms, they have to agree both in the variable. So we've got those x's, but they also have to agree with the exponent. Here we have a 2, and here we have an exponent of 1. So those are not the same. So there are no like terms in this first set of parentheses. So we can remove that. There's nothing that you can combine. You have 3x squared plus 2x minus 8. Now we have another collection within that we're going to add the sum of these items in the parentheses. Well, let's see, is that really in there? We have the same situation, x squared, x, and no variables. Even though the variable is the same, it's an x, it's not agreeing with exponents. So there are no like terms here, because we're adding. We have plus 5x squared minus 3x plus 9. Now we can look at this expression here and combine like terms. See, we've got an x squared and an x squared. The way you combine like terms, just as if you have 2 apples plus 4 apples, you don't come up with 2 plus 4 is 6 apples plus apples. You don't have you say you have 6 apples plus apples or 6 apples squared. You just add these coefficients. 3 plus 2, 3 plus 5 is 8x squared. And it's perfectly fine to draw a slash through terms, pieces of your algebraic problem when you're working with them, if you need to. We've got an x there, and an x there. How do we combine these like terms? Add the coefficients. You have 2 minus 3, or 2 plus a negative 3, becomes a negative 1. Now, am I going to write negative 1x? No. If I just say negative x, I understand that there's only one x there, and I don't write that. So I've used, combined my x terms. Now, I only have numbers left. And what's that name for the number that's in our polynomial? Okay, that is simply a constant term, so we want to combine those. Negative 8 plus 9 is a positive 1. Now, I think this should be the solution to combining this expression. Well, let's see. 8x squared minus x plus 1. I have two variables of x here, but their exponents are different, so I don't have any like terms, and that's my solution. Okay, the last one, I think, that I'm going to go ahead and do on this, the last example. Now this goes back to the distributive property. We reviewed this very briefly, but the technical title of it is the distributive property of addition over multiplication. And it tells you what you do when you have an expression that looks like this. Because here we have it's multiplication over addition. We're using a factor here, and we're going to multiply it against the sum of something. And what that says is when you multiply a factor against a quantity within parentheses, you have to multiply that factor against every individual term within inside those parentheses. So first you're going to say 4 times x. And then we have plus, now we're going to multiply the 4 against the 2y. Let me use this dot, lose the dot. I have 4 times x plus 4 times 2y. And that's all we're going to do when we distribute this. But we're not finished yet because we don't want to leave all those parentheses there. 4 times x just becomes 4x. Remember, when we have a product of a constant term and a variable, just bump those together. Now we have 4 times 2 times y. Can you multiply 4 and 2? Yes. 4 times 2 is 8. Why? Because what you're doing here is you're saying you have 4 groups of 2y, so you have 2y plus 2y plus 2y plus 2y. What's 2 times y? Y plus 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 y. 1, 2, 3, 4, 5, 6, 7, 8. That's the shorthand notation that we use in algebra to indicate adding together all these individual y's. And this is why we really like to be able to do multiplication. Okay, so this is what the distributive property really is showing us. But what happens if instead of having 4 times x plus 2 times the quantity x plus 2y, we had negative 4 times the quantity x plus 2y. Listen carefully to how I'm pronouncing this. When you have the parentheses, it's read the quantity and then whatever's inside it. So this is negative 4 times the quantity x plus 2y. We're distributing, so what we have is a negative 4 times x plus what? A negative 4 times 2y. So when you're using the distributive property, the sign of that outside factor goes along with it when you're multiplying it. I mean, we didn't say plus 4 times x because you know that a number's positive if it doesn't have a sign in front of it. So when you have the negative, don't forget that you're multiplying by a negative. Negative 4 times x is minus 4x. Now this says, let's add the product of a negative 4 and 2y. So negative 4 times 2, we have plus a negative 8y. We're adding a negative product. This can also be written as minus 4x. To add a negative is the same as subtract. Minus 8y. Okay, look at that. Make sure you understand what's going on. Use that little pause, rewind, replay. This right here where you're distributing a negative is one of the very, very most important techniques to make sure that you understand with your algebra, because it will trip people up over and over and over and over. Call it dropping a negative or forgetting to distribute the negative. So I told you what the distributive property, gave you examples of it. Let me show you the algebraic expression of the distributive property. This is the distributive property of multiplication over addition. That says if you have a general expression that takes the form a times the quantity b plus c, that's the same as a times b plus a times c. And that's where you take the outside factor, the outside term, I don't really want to say term, but that outside value here, and use it as a factor with every single individual term that's inside those parentheses. So, the last problem that I want to do here is 4a cubed b plus 2a squared b minus 8ab cubed, that whole quantity, minus 5a cubed b plus 3ab squared minus 4ab cubed. Always take the extra few seconds to go back after you've written the problem. Make sure you've written it down correctly. So I have 4a cubed b plus 2a squared b minus 8ab cubed minus 5a cubed b plus 3ab squared minus 4ab cubed. Okay, remember, order of operations says work inside the parentheses first. Do I have any common terms here? No. This is a cubed b, ab cubed. We have an exponent of 1 and an exponent of 3, but they're on different variables. So this is actually 4 times a times a times a times b. Well, this is 8 times a times b times b times b. So they're not like terms. We can simply remove the parentheses here. 4a cubed b plus 2a squared b minus 8ab cubed. Now, do we have any like terms in here that we can combine? No, there aren't any. Look what we've got though. We are distributing a negative sign. This is actually saying -1 times this quantity. So what you have is, let's say, plus a -1 times 5a cubed b plus a -1 times what? Times 3ab squared plus what? A -1 times a negative plus a -1 times a -4ab cubed. You're distributing that negative. See, that negative has been used as a factor against each one of these three terms that are inside the parentheses. Now let's do our multiplication again. 4a cubed b plus 2a squared b minus 8ab cubed plus what? Plus a negative. To say plus a negative number is the same as subtraction, so I'm going to change that to a minus 5a cubed b. I hope you're all very comfortable with going from this step to here. If you're not, consider it, chew on it, practice it. If you're stuck, call me. Plus a negative 3ab squared is minus 3ab squared. Plus, okay, well we have negative 1 times a negative 4. Negative 1 times negative 4 is positive. Whenever you multiply two negative signs together, got your train crash, you've got a plus sign. So that becomes plus 4ab cubed. Now, are we done? No, first we have to see if we have any common terms, any like terms. Let's see. I have an a cubed b, a squared a cubed b. So these right here are like terms. 4a cubed b minus 5a cubed b gives us a negative 1a cubed b. That's negative 1a cubed b. You don't write the 1. So I've done with those. Now let's walk down from the a cubed to a squared to a. Okay, I've got a single a squared, a. Nothing to combine with, so that's plus 2a squared b. Now let's look and see what I have if I just have an a by itself. A, b, and nope. Well, let's see if I have an a times b squared. B cubed, here's an a times b squared. That's the only one there is. So this is minus 3a b squared. I have these two terms left. ab cubed, ab cubed. They're like terms. We can combine those. Minus 8 plus 4 is minus 4ab cubed. Let's go ahead and see if I've gotten the same answer. Minus a cubed b plus 2a squared b minus 3ab squared minus 4ab cubed. This is the end because you have no more like terms that you can combine. You have distributed the negative sign. Now, I do want to go ahead back to here. This is what our expression looked like after we distributed that negative sign. Inside the parentheses it had been a positive 5a cubed b, now it's negative 5a cubed b. Positive, negative, negative, positive. What happens when you distribute a negative sign to, across parentheses, is the sign of every term inside those parentheses changes. So that's the end of a very long lecture on section 1.2. I hope it's cleared up things for you.